So I'm hoping that as we talk about the planets, the rocky planets first and then the gaseous planets, you kind of get a sense for what would it be like if I were to stand on the surface of that planet, or kind of what does that planet look like in general. So kind of lined up here, we have Mercury, kind of the gray looking thing, kind of looks, doesn't Mercury kind of look like Earth's moon? And Venus, actually Venus, if you look at the planet itself, it's kind of shrouded in clouds, and it does have kind of a cool topography underneath the clouds. Then of course we have Earth and Earth's moon, and then Mars has got this cool reddish look to it. So kind of, we'll talk more about that. But one of the things is the surface of the planet kind of tells a story about what has happened to that planet ever since it was a planet. And here's what I mean. If we kind of go back to Earth and we kind of think of the ways in which Earth has been affected with regard to its surface features, one of the things, I'm going to show you a big crater that's been around for a while on the Earth's surface, craters. So, but if I were to ask you what has more craters, the Earth or the Moon, you'd probably say the Moon has more craters. And you're right, and part of that is just, how do I say part of it, but basically all of it, the reason the Moon has more craters is it hasn't had all these resurfacing things that I'm going to talk about with regard to the Earth. So there's that big impact crater I was telling you about in Winslow, Arizona, just like the song, on Earth. Okay, it's a big impact crater. And this is one of many craters on the Moon. This is Tycho. And kind of, it's beautiful. Can you kind of see that central peak? There's a shadow that kind of is falling. It's just a very gorgeous picture. So Earth basically has resurfaced itself since long ago, when there was all sorts of miscellaneous stuff running around the solar system causing bombardment pockmarks. Okay, so the Earth's surface used to be just as cratered as the Moon. That's one way to think of it. But the Moon hasn't had volcanism. Well, it has just a little bit, but in general, it hasn't had volcanism to go ahead and repave it. Okay, so that's one way the Earth's surface has repaved itself, and we can look at this phenomenon with the other terrestrial planets. Okay, not necessarily repaving itself, but its surface, but related to tectonics. Basically, when the crusts move apart and material can shoot up, some of that material can be gases, and it's kind of cool because those gases can stick around and give a planet like the Earth its atmosphere. It's pretty exciting. So tectonics, or plate tectonics, are shown here, and can you kind of see the little convection cells? There's 3 convection cells being shown there, and you see the lithosphere kind of moving, kind of converging over here and diverging right there. Okay, so as we have lithosphere moving around on liquid mantle, that actually is going to have subduction zones where the Earth's lithosphere, or the crust, is kind of subducted and we get new crust build up. So again, it's a way to kind of resurface what we look like. So this, if I were to animate it, would kind of show you another way to kind of look, to give a planet a different look. And again, it goes back to tectonics, is with tectonics you can go ahead and have land masses move and be totally different patterns as they once were. So if you're familiar with the supercontinent called Pangaea, you know, thousands, millions of years ago, basically all of Earth's landmass was kind of stuck together. And then with tectonics, it has spread apart. Okay, that says 200 million years ago. Another way that a planet's surface can be changed is with water, flowing water. Now, this is an extreme example of a river that has flown for eons, the Colorado River, to create the Grand Canyon. So just a little bit of water can make a big old dent. Actually, with regard to water creating a pattern like that, we see on Mars how flowing water has created these patterns that have been preserved. So ice can go ahead and resurface the surface of planets. So if you're familiar with the Earth, actually, if this is the polar region, we have had ice ages where, just like the movie, ice ages where ice is glaciers, came towards the poles, and then the glaciers retreated. The glaciers came towards the equator, they retreated towards the poles, they came towards the equator, retreated toward the poles, etc. So in doing so, they actually had resurfaced and relocated rocks. I mean, studying past glaciers is kind of an exciting thing, I can imagine, too. Another thing that kind of resurfaces Earth's surface is wind erosion. And actually there is definitely a fair share of wind on Mars. If you've ever seen, there are actually these Martian dust devils. It's kind of a cool sort of thing. So wind can kind of be an abrasive mechanism to change our surface. And just flowing debris can change the surface of a